After successfully completing this lesson, you'll be familiar with the operation of reciprocating pumps, single and double-acting reciprocating pumps, the operation of several different rotary positive displacement pumps, the relief valve in positive displacement pumps. Positive displacement pumps have one of two basic designs, either reciprocating or rotary. Positive displacement pumps differ from centrifugal pumps in that they use mechanical energy to transfer fluid. If the displacement is on the forward stroke only, then the pump is single-acting. This pump is double-acting because it displaces liquid both on the forward and return stroke. Here's an illustration of a reciprocating pump system. Positive displacement pumps are capable of delivering very high pressures. These pressures can be much in excess of the design pressure, and so a relief valve must protect the pump. Positive displacement pumps are self-priming, as the suction and delivery are positively separated during pumping. However, in order to reduce wear and ensure quick starting, an external priming connection from above the pump should be available. Reciprocating pumps can produce pressure fluctuations in the discharge pipelines. A damper, either gas or air-filled, can help to even out the pressure fluctuations. The damper stores some of the energy as the pressure rises and releases this energy as the pressure falls. Most positive displacement pumps in use are of the rotary type. Rotary pumps operate in a circular motion and displace a constant amount of liquid with each revolution of the pump shaft. This is accomplished by the pumping elements moving in such a way as to expand volumes to allow liquid to enter the pump. These volumes are contained by the pump until the geometry causes the elements to move to reduce the volume and force the liquid out. The clearances of the elements within the pump separate the suction from the discharge and are critical for efficient operation. Rotary piston-type positive displacement pumps are found in hydraulic systems. There are two types, radial piston and axial piston. You can see that the pistons rotate eccentrically to the rotor axis. This causes the cylinder volume to increase as the pistons pass the suction port and decrease as the pistons pass the delivery port. In some applications, such as steering gear applications, the pump can have a variable discharge. This is achieved by increasing and decreasing the eccentricity of the pistons, thereby changing the amount of cylinder volume increase. The nature of the ports can also change by moving the piston eccentricity past the pump center line. An axial piston pump is sometimes known as a swash plate pump. The principle is the same as for the radial type. An axial piston pump can also be used as a variable delivery pump. Gear pumps rely on the meshing of gear wheels to separate the suction and delivery ports. They come in two configurations, either internal gear or external gear. Internal gear pumps use the same principle as the external type. In this case, the driven gear has internal teeth and meshes with the idler, which has external teeth. The external gear pump has two gear wheels, one driven by the motor and the second, or idler, which is driven by the meshing of the gears. The gears carry the liquid around the outside, and the meshing of the teeth cause the liquid to be discharged. Screw-type pumps usually have either 2 or 3 screws. They can operate at high speeds and give a smooth discharge with almost no pulsations. They come in 2 configurations, either twin screw pump or 3-screw pump. The twin screw pump uses a similar principle to the gear pump, the screw and the casing. The meshing of the screws causes the liquid to be discharged. Due to the imbalance of forces, this type of pump often has the suction arranged at the center of the screws and the delivery at either end, and is often driven through timing gears, which keep the screws from contacting each other. The 3-screw pump is usually arranged so that the central screw drives the 2 outer screws. A special type of screw pump is the single screw or progressive cavity pump. This pump has a single screw rotating in stator. The stator is made of an elastomer material. The stator has an internal helix of different pitch to the rotor. The geometry means that the rotor moves vertically whilst turning, so the meshing of the rotor and stator causes the cavity to progress to the discharge. The screw is an interference fit in the stator, so this pump must always have liquid present to prevent overheating and failure. Vane pumps come in 2 configurations, either flexible vane pump or sliding vane pump. The rotor is made of an elastomer, and as the vanes pass the cam, they deflect, decreasing the cavity and so discharging the liquid. The vanes are a sliding fit in slots cut in the rotor. The rotor turns eccentric to the casing, causing the cavities to decrease in volume. Vanes can be forced out by centrifugal force, use springs, or utilize the pressure of the discharge liquid. Congratulations! You've completed this lesson.